Sauté lardons in butter. This was the first instruction given in many recipes at Jacques Pepin's French Culinary Institute when I attended in 1998, now the International Culinary Center. Lardons are pork belly cut into strips, and the recipe always called for an equal weight of butter and lardons. So you can see that the relative saturation levels of pork belly and butter. You can see that the butter is significantly more saturated than the pork belly, containing 2.5 times as much saturated fat for the same weight, yet less monounsaturated fat and half of the polyunsaturated fat. We talk about these things both as being saturated fats, but the French chefs knew. The French love their pork and they love their chicken, but they know to combine them with butter. That is traditional wisdom being handed down. When I was at the French Culinary Institute reading these recipes, I would say to the chefs, "Are you sure it's okay to use all this butter? Isn't this going to give us heart disease?" And the chefs were completely unfazed by this. They would say, "Look, this is how people eat in France and they're fine, so don't worry about it." That was the first time that I, a boy that grew up in the low-fat craze of the 1990s in the US, really started to question that maybe the things that I had been told about saturated fat were wrong. The chefs were handing down old-school traditional wisdom to me. They knew more than the nutritionists did. You can see that when you combine these two fats, you end up with an end product that is 57% saturated, 37% monounsaturated, and only 7% polyunsaturated fat, and that is the basis of French cuisine. You can see this pattern in actual dietary records going all the way back to 1961. You can see that the French diet is dramatically based on butter and meat. They don't eat hardly any olive oil. Sunflower oil is the most prominent currently used vegetable oil in Europe. These four sources, butter and dairy, meat, olive oil, sunflower oil, represent the vast majority of added fats in the current European diet. I listed these in order of decreasing saturation. The butter is obviously by far the most saturated, then pork. And when you say meat in Europe, you almost always mean pork. Then olive oil, which is obviously mostly monounsaturated, and sunflower oil at the bottom, which is largely polyunsaturated. And you can see that by 1980, a dietary trend has set up where the French are eating mostly butter and dairy and meat. Italians are eating mostly monounsaturated fats in the middle. The Spanish are eating more towards the bottom of olive oil and sunflower oil. All of this data, by the way, is from FAO Stat, which is from the Food and Agriculture Organization of the United Nations. And you can see this comes from food balance data. This is economic data of all of the products sold in those countries. And obviously that's mostly what they eat. Again, here you can see this trend of France eating butter and meat, Italy eating mostly monounsaturated, and the Spanish eating a combination of monounsaturated and polyunsaturated oils for the most part. This trend goes on. Here's the year 2000. The French have added some sunflower oil, but the diet is still dominated by dairy and pork. The Italians, even up to the year 2020, are still not eating a lot of polyunsaturated fat. They're still focusing on the middle here, olive oil and pork with some butter. And the Spanish, of course, are still down here at the bottom, consuming a lot of monounsaturated fat and a lot of polyunsaturated fat. Our first metabolic challenge is obesity. The French are in the light yellow and red jerseys, representing butter and pork. The Italians are in the olive drab and red, representing olive oil and pork. And the Spanish are in the bright yellow and olive drab, representing sunflower and olive oil. After my last video, how olive oil makes you fat, a lot of people said, "Are you crazy?" Everyone knows that the Italians are very lean, and this study from 2014 shows you exactly that. Look how lean the Italians are here at the bottom. In fact, no one is even close. 70% of Italian women are of normal weight in 2014. No one is even close to that in Europe. You can see the French are fatter, and Spain significantly more problems with their waistline. Do we call this a win for Italy? This paper comes with a punchline. This paper is based on self-reported anthropometric characteristics. This means that they sent a survey to Italian households and said, write down your height and weight. And the Italians wrote down their height and the weight they were in high school and sent them back in. But there are other studies done in Italy. And in fact, this is the study that I showed in that video where weight and height are actually measured by healthcare professionals using an electronic scale with a digital display, or later a balance beam scale. And the height was measured using a height ruler, but again, by healthcare professionals. So this is perhaps a more accurate representation of BMI in Italy. And you can see that, in fact, in the year 2008, 23% of women in Italy were actually obese versus 8% who volunteered that they were obese on a self-reported form. Luckily for us, we have similar studies done in Spain in 2008 through 2010. It says this is the first study to report the prevalence of obesity based on actual measurements of weight, height, and waist circumference. We have a similar study done in France in 2006. Anthropometric measurements were taken by a trained nurse in a physical examination. So using these three studies, we can do a relatively apples to apples comparison of obesity rates in France, Italy, and Spain. And what do we find? The France are in fact significantly thinner. These studies measure people up to 75 years of age or so. So a 70-year-old being measured in France in 2006 would have been in their 20s in 1961. And that goes back to those tables that I showed you, dietary trends all the way back to 1961, because it's relevant. The people being measured in these studies were eating that diet all the way back to 1961. And so a lifetime of butter and meat left the French leaner than a lifetime of olive oil and meat in Italy, or a lifetime of olive oil and sunflower oil in Spain. And it's not really that close. You can flip a coin on who is more obese between Italy and Spain. Honestly, I would call it a statistical tie. That leaves the standings after our first contest of France representing butter and pork undefeated at 2-0. Italy loses to France and ties with Spain, leaving them at 0-1-1. Spain loses to France and ties with Italy, leaving them also at 0-1-1. Event 2 is diabetes. All of this data comes from the Diabetes Data Portal by the International Diabetes Federation. To my knowledge, this is the single best resource for country by country diabetes data. And what do we have? Well, again, so going back to 2011, France, Italy were very close. Spain was a bit ahead, but by 2021, Italy has clearly moved out into the lead over France. France at 5.3% diabetes rate. Italy inching up to 6.4, and Spain way out in front, 10.3. Spain is one of the most diabetic countries in the world. The U.S. rate by comparison is about 10.7. So 1 out of 10 Spanish adults are currently diabetic. This is projected to rise to 1 out of 8 Spanish adults by the year 2040. So a lifetime diet of olive oil and sunflower oil has produced a very diabetic country in Spain. Italy is projected to increase their rates up to 8% by 2040 by the statisticians. And France is projected to rise slowly, only reaching current Italian levels by the year 2040. So France pretty easily wins the diabetes portion of the contest, with Italy beating Spain quite handily. So that leaves our standings with France still undefeated at 4-0. Italy picks up their first win, moves into second place, and is now 1-2-0. And Spain, eating MUFA and PUFA together, is way back at 0-3-1. Okay, before we go to the final event, let's check in with a lab. This experiment is very thorough. They fed mice a variety of diets focused on saturated fats, mostly monounsaturated fats or mostly polyunsaturated fats. You can see the coconut oil diet is very saturated indeed. They used hydrogenated coconut oil, and there's almost no monounsaturated fat or polyunsaturated fat in it. The soybean oil diet is, as you would think, mostly polyunsaturated fat. We're using 2 different monounsaturated fats here. One is called Plenish, which is a high oleic soybean oil. And the other one is, of course, olive oil, checking in at 76% of MUFA, the MUFA champion. And the last one is lard. And you can see lard is plurality MUFA, but with a significant amount of polyunsaturated fat. That lard is 22% polyunsaturated fat. That is very high PUFA lard, and you get that from American lard when they're using very lean breeds of pigs and they're feeding them diets that are high in corn and soybeans, which are both high sources of polyunsaturated fat. And so that lard diet is very devious in creating obesity. As you will see, that combination of MUFA and PUFA is the best for that. I'm the proprietor of firebrandmeats.com. By the way, if you want to get old-fashioned pork like those French chefs would have used. In France, pigs were finished on barley. That created pork that was very low in polyunsaturated fat. And you can see Firebrand Meats pork is only 6% linoleic acid compared to 15.6% linoleic acid in a sample of Smithfield rendered bacon fat that I sent in. Or in this experiment, the lard they're using is 22% polyunsaturated fat. So you can get a lot of polyunsaturated fat from lard. That's not what you want. My lard is also higher in stearic acid, which is a saturated fat that is associated with a lot of good metabolic benefits. If you're going to choose to use pork in your diet, Firebrand Meats is the place to get it. So what happened with these mice? You can see the gray line there, the VIV, that is mice on a high starch diet. Mice stay very lean on a high starch diet. It's a very low fat diet. But the mice fed that coconut oil. You see I have saturated fatty acid written there. Those stay quite lean compared to the others. The mice given the monounsaturated fat. So I have monounsaturated fat plus saturated fat because this is actually a 50-50 blend of that coconut oil and the Plenish. Those mice get considerably fatter than the mice fed the pure saturated fat. And of course, the mice fed half coconut oil and half soybean oil become even fatter. An interesting thing about this chart is that the mice fed the monounsaturated fat diet actually stay very lean for the first 4 or 5 weeks. They in fact stay just as lean as the low-fat starch-fed mice. Over the next 3 weeks or so, they keep pace with the mice fed all saturated fat, but ultimately, as the mice go through puberty and their body growth slows, they become more obese. And that's interesting because this is from that Spanish obesity study. You can see that in Spain, in the younger people, abdominal obesity is not so prevalent. But when you get to 60 years of age in Spain, 62% of the people have abdominal obesity. If you look at the women, that's even higher. 70% of Spanish women over 65 eating olive oil and sunflower oil have abdominal obesity. Again, back to that mouse study. This is another feeding trial they did. This is now no longer cut with the coconut oil. This is the pure thing. This is 40% coconut oil versus soybean oil versus that high PUFA lard, which is a mixture of monounsaturated and polyunsaturated fats. And so you can see that indeed the soybean oil mice become obese, but the mice fed monounsaturated fat with the polyunsaturated fat become even more obese. The obesity is associated with oxidized linoleic acid. That's oxidized polyunsaturated fat, this 9,10-dihode, 12,13-dihode. These are signaling molecules that happen when linoleic acid from soybean oil gets oxidized. And you can see that these things are associated with increasing body weights, but the monounsaturated fat diet produces more of these linoleic acid metabolites than does the saturated fat diet. I showed why in the last video. So soybean oil gets converted to arachidonic acid, which gets converted to all these oxidized linoleic acid metabolites, which are associated with obesity. But the enzymes that oxidize those omega-6 polyunsaturated fats are increased by monounsaturated fat. And so this is where you see olive oil increasing the levels of D6D and D5D, the enzymes that oxidize the PUFA. The MUFA-fed mice have more oxidized lipids and they are fatter than the coconut oil-fed mice. And you think, well, that's because there's no linoleic acid in the coconut oil diet. But that's actually not true. In all of these experiments, they're always worried about essential fat deficiency. They think that Animals that don't get any linoleic acid will be in really bad shape. And so what they do is they sneak some soybean oil into the coconut oil diet. So you can see in that coconut oil diet, 2% of their calories are from linoleic acid. But in the monounsaturated fat diet, they decided this diet has enough linoleic acid at 1.4%, and so they don't have to add any extra soybean oil. So looking back at this chart again, in the coconut oil diet, this is actually 2% polyunsaturated fat, but has significantly less oxidized polyunsaturated fat. In the monounsaturated fat diet, it has almost a third less polyunsaturated fat in the diet, but it has significantly more oxidized polyunsaturated fat. And that is because monounsaturated fat, by upregulating delta 6 desaturase and delta 5 desaturase, drives the oxidation of polyunsaturated fat. Not everyone wants to hear that, but I'm here to tell you the science. Also, these experiments show that mice fed the monounsaturated fat and polyunsaturated fat diets are insulin resistant. So GTT, that means glucose tolerance test. So these are the mice fed a low-fat starch-based diet. What happens is you just feed them a bunch of straight glucose, and then you measure their blood glucose over the next 2 hours and see what the area under the curve is. That's what AUC. That's how high did their blood sugar go over the next 2 hours? That's what this test is asking. You can see the starch-fed mice are pretty low. These are the pure saturated fat mice. They do okay. And these diets are not the ones split with coconut oil. These are the straight thing. So this is soybean oil here. They do very bad on a glucose tolerance test. This is Plenish. So this is a 73% monounsaturated fat, 77% polyunsaturated fat. They're significantly more insulin resistant than the mice fed the saturated fat diet. This is olive oil. The olive oil diet is even higher in monounsaturated fat than the Plenish, and they're more insulin resistant than even the mice on the Plenish, and significantly more insulin resistant than the mice on coconut oil. And this is the lard diet. So these have the base of the diet is monounsaturated fat, but they're also getting a ton of PUFA, and they are the most insulin resistant. Furthermore, the mice fed MUFA have fatty livers. Now, look at this chart. This is liver as the percent of the body weight of the mice. So these coconut oil fed mice here in blue, this is 0% monounsaturated fat, right? And about 4% of their body weight is their liver. Now, these mice are fed olive oil, right? So that was, I think, 76% monounsaturated fat, and their livers are about 6% of their body weight. So that means that their livers have basically swelled by half with stored fat. These mice absolutely have fatty liver, and you can see that the two diets that are highest in monounsaturated fats have the most fatty liver. So this is Plenish and olive oil. And lard, which is intermediate in monounsaturated fats, have the next fattiest livers. And the soybean oil fed mice actually didn't do that badly from a fatty liver perspective. And so we can graph this as MUFA content against liver as a percent of body weight. And you can see that monounsaturated fat content of the diet is absolutely driving liver fat accumulation in mice. Lastly, this is just a visualization liver tissue, and they put it on slides. In the red is the staining of the fat. So anywhere you see red, that's fat. You can see these coconut oil. So these are 4 different mice fed coconut oil, and you can see none of these mice have significant fat accumulation. This is the soybean oil fed mice, and this one's very interesting because 2 of them are actually very, very low in fat indeed, but 2 of the others have significant fat accumulation due to the soybean oil. But here, lard, Plenish, and olive oil, all of the mice fed a significant amount of monounsaturated fat, have significant liver fat accumulation. So that's 12 times out of 12 you see that liver fat accumulation in monounsaturated fat fed mice. So on to our third contest. This is a study of non-alcoholic fatty liver disease between France, Italy, and Spain. And as you might predict, based on the last slide, the Italians have the highest rate of fatty liver disease, followed by the Spanish, and of course, again, the French win and have the lowest levels of fatty liver disease. So that completes our standings, with France in the light yellow and red dominating the league at 6-0. Italy and Spain tied in a distant second place, representing olive oil and pork, and sunflower oil and olive oil, respectively, each at 1, 4, and 1. Check back in soon. I'm super excited about the next video. We're going to talk about why the ratio of saturated fat to monounsaturated fat matters so much. We're going to get deep into the science of that. That harkens back to that first slide with the lardon sauteed in butter. The knowledge of the French chefs knowing that they had to add saturated fat to the pork fat before serving it. And we're going to talk about how you can battle your own stored monounsaturated fat with succinate. I'm very excited. I finally have disodium succinate capsules, 800 milligram capsules in stock, 120 capsules a bottle at fireinabottle.net/shop. I'm so excited about this product. I've only gotten mine about 2 weeks ago. I'm having great luck with it. So we're going to have a lot more about that product in the next video and how it works and why you should be taking it. Come back next time.